Welcome to the today webinar about advanced drive systems for laboratory automation. I'm Sandra Walter and you're today's host. I'm working at Maxon since almost 5 years. In my role as a business development manager in the business unit Industrial Automation at the headquarters in Switzerland, I take care of the global laboratory automation market. I support our subsidiaries and salespeople at the front during customer projects and try to better understand the needs of customers in the lab automation market and then develop new products to the needs of the customers. So today's agenda. First, to better understand what's important when choosing the right motor or drive system for your system, we will quickly have a look at the history of laboratory automation. Then it is shown how the right drive systems can be selected to improve the instruments by using different application examples. And finally, I will briefly introduce Maxon. So what Maxon offers, what know-how and network we have, and how we can help you. So laboratory automation has its starts in the 1950s. The first instrument was an auto-analyzer 1 that was used for continuous flow analysis to increase the instrument throughput. In the end of the 1970s, the pre- and post-analytical workflows were still handled by laboratory staff. This alone has consumed 60% of the time and effort in the specimen workflow and have caused many errors in the lab. Because of that, more efforts were made to automate the lab. Masahide Sasaki is credited to be the father of total lab automation. In the 1980s, he created the first automated laboratory with conveyors, belts, circuit boards, and programmable robots. This helped to automate the process for pre- and post-analytical workflows and led to the first fully automated clinical laboratory. Nevertheless, today there still exist different degrees of automation in the laboratory. Some steps are still carried out by hand, mostly single steps. On the other hand, other processes are carried out by using individual standalone apertures, where the samples are then transported back and forth between manually or with the help of other automation solutions like robots, for example. Last but not least, in larger labs, the whole process is fully automated and multiple processes are handled automatically. And this considered as a total lab automation system. Samples are transported with conveyors between the single steps and less manual steps are required. So where is the trend of laboratory automation going? Lab automation has become flexible, modular, and mobile. By working with collaborative robots instead of large total lab instruments, individual instruments can be connected. This allows more flexibility in the laboratory, and at the same time, the throughput can be adapted to the requirements. However, it has also been shown that because of the cost pressure in this market, there is a trend towards central laboratories, which process the individual steps fully automatically with a high throughput. Total labs offer the advantage that if the design is successfully implemented, the costs are lower in the end, in the long term, also because often less staff is required. In addition to that, there are many other advantages, such as efficiency, standardization, and improvement in testing quality. However, the investment for such a total lab automation system is very expensive and may be an issue for some facilities where the budget allocated to the lab is very low. It turns out that the trend is in the direction of both total lab systems and labs with individual connected robots or conveyors. In general, it can be said that the trend is towards more automation. So what are the challenges and important things needed in the laboratory process? To perform a large number of analyses in a short time and to handle the increasing number of test samples. laboratories need accurate and highly reliable data. To achieve this, labs have installed automated sample transportation lines and automatic analyzers. This leads to the need for reliable automation systems that perform always the same way to have a high reliability. Another reason as well why automation is important in the laboratory is the need for higher throughput volumes. Automation increased throughput times and accelerated research processes. Last but not least, reliability is a very important point in a lab process. More than 70% of the researchers have tried and failed to reproduce another science experiments according to Nature survey. Through the use of automated processes and the use of corresponding electromechanical systems, drive systems, reproducibility, throughput, and reliability can be increased. The question then is, what is the right motor technology to choose from now? So we have talked about what is important in the laboratory just before. When a product instrument is developed for the laboratory, the question arises which drive technology is the best suited for the design product. Well, there are many different drive technologies on the market, from brushed to brushless, servo motors with or without iron core, to stepper motors or direct linear or rotary motors. There are many. As well-known supplier of different drive technologies, Maxon has been able to gain a lot of experience in all different technologies. So there are different aspects to consider when selecting the right drive system. If you want to build a dynamic system that can accelerate the brake quickly, internal rotor motors are the best. They are characterized by a lower rotor inertia and thus enable faster acceleration and braking. These includes the Maxon ECX and EC and ECI motors. These motors are recommended to use for highly dynamic and fast applications. For applications with higher speed range, the ironless motors with an efficiency of up to 90% are the best because they have less iron losses in the system. They can run much faster than iron core motors. The iron core motors, on the other hand, can achieve higher torques, but have a lower degree of efficiency and less speed. Stepper motors, for example, have a very high torque, but there is this risk that the steps will be lost during the operation. And in order to guarantee a good repeatability, it is recommended to use ironless motors and to use as few as possible mechanical components in the system. Then, in combination with a high resolution encoder and the cogging-free ironless motors from, for example, Maxon, precision and repeatability is guaranteed. In the case of iron-based motors or stepper motors, the large cogging torque can become a problem in integrated in regards to accuracy and repeatability. Thanks to 100% output inspection of all Maxon motors, they have only a very small variation in production. This is an essential point in terms of reliability in your application because the motors have a very good consistency over all instruments that you will manufacture. In addition, thanks to the ironless Maxon motor windings, Maxon motors have a higher efficiency, and thanks to the very high filling factor of the ironless windings that we have, they also have a very high power density. So let's start with a simple decapping application as an example. In this application for a decapper with 96 single axis, we decided to use an EC motor and gearbox and EPOS4 microcontroller. The reason why an EC motor was used was its lifetime, because the EC motors, depending on the load, can have a lifetime of up to 10 or 20,000 hours. In addition to that, because the EC motors are brushless motors, a potential contamination of brush dust in the system is prevented. Also, because of the use of the integrated hall sensors of an EC motor, no additional encoder was needed. In this way, the overall solution was cheaper despite of the use of a more expensive EC motor in this case. And thanks to a very small EPOS4 microcontroller, it was possible to control each single axis individually. And in this specific project, the customer appreciated the know-how in the field of drive technology that we could offer, the intensive support in the field of electronics and motor selection. And last, because Maxon was able to offer all from one single source. So next example, pipetting. Pipetting, especially electronic pipetting, is considered to often use stepper motors. However, the use of ironless EC or DC motors would make pipetting more dynamic and faster compared to stepper motors. In addition to that, due to the increased efficiency of ironless motors, it would draw less current so that the battery can supply the motor for longer and has to be charged less. And thanks to the wide range of the Maxon offering, so the spindle drive, motor, gearbox, and controller from one single source, we were able to offer a cost-competitive solution compared to a stepper motor solution, with, in addition, having a technical advantage over the other technology. And as already said, reliability is a very important factor in the laboratory. This means that devices have to work reliable and precisely. By using an absolute multiturn encoder, for example, the absolute position can be saved and called up at any time. This ensures that despite the interruption of the analysis process, the exact position is known and the process does not have to be repeated. Maxon's new absolute multiturn encoder, for example, has the advantage that the harvesting technology used in the encoder ensures that no additional battery is required, and that the position is saved in the encoder even if the load is moved when the instrument is turned off. This means that the classic homing reference run that is normally done in applications where you don't have absolute positioning system is not necessary, and much time during the process can be saved. And thanks to the very high single and multi-turn solution of 16 and 17 bits in this example, the high precision positioning is also ensured. Especially in typical XYZ applications, the absolute multi-turn encoder can ensure a better repeatability and reliability. So while we'll talk about liquid handlers and XYZ applications, so what drives would be a good choice for such applications? Often stepper motors are used now, but DC motors and iron core ECI motors are suitable because they can provide high forces in a very small space. By using an ironless motor, a very compact drive system can be used to achieve high power and drive dynamically the axis and still having a high precision. With that, there is more space in the instrument for other parts, or the instrument can be designed smaller. And in combination with the maximum multi-axis controller, each axis can be operated parallel so that you can save a lot of time in the process and the throughput of the whole instrument can be increased. And last, ironless motors also have the advantage that they cause very little EMC, electromagnetic interference, which is a great advantage in some applications. For example, stepper motors, which are iron core motors, cause higher EMC than the ironless motors. So in many applications, especially in point-of-care diagnostic or very small devices, it is necessary to have a very high power density because you don't have a lot of space. Maxon's new ultra power gearboxes have needle roller bearings and very tight tolerances in each single planetary gear wheel. This, as a result of that, ensures very high efficiency, and efficiency could be increased compared to standard gearboxes, and as well the maximum transmitted power. So this example, the gearbox GPX8 Ultra Power can have an efficiency of up to 90%, depending on how many stages you have. in combination with a maxon 4-pole technology, which was previously just available for 22 millimeters motor and is now planned to be available down to a diameter of 8 millimeter, you can have much more power in a very small space. And in combination with the gearbox and this motor type, the efficiency of the whole drive system can be up to 75%, which is way much more than other comparable motors and gearboxes on the market. And this just at the diameter of 8 millimeter. So beside that, Maxon also works closely with research institutions, for example, CSEM. In cooperation with CSEM, a new pump technology was developed which enables a bidirectional linear flow, which is an advantage over classic syringe pumps, for example. On the other hand, while classic pumps, many classic pumps has a pulsation, this technology is almost pulsation free, which is a huge benefit. And the pump was specifically developed for the life science area and enables the pipetting of small drops down to 0.8 microliter. Depending on the requirements, the pump can also be designed to be suitable for the pharmaceuticals, for the pharmaceutical markets, depending on what material you choose for the pump, for example, Titan. And one example here shown is the design on the bottom right, a customer-specific design which was developed for a medical customer, and on this pump specifically can produce a pressure up to 1.7 bar, and all this on a diameter of just 8 millimeter. And last, another interesting technology for laboratory automation are linear motors. Since there is an increasing demand for higher throughput, reliability, and precision, direct linear motors can be a good choice. Linear motors are direct drives and therefore have a higher precision with the right encoder without having lower speeds. So you have high precision, fast acceleration, and high speeds. In markets such as semiconductor, they have been used for years, and more markets are starting to adapt to this technology right now. So Maxon has been working on customer-specific solutions in the past for linear motors and is planning to do even more. If you have thought about using linear motors, let us know. So how can Maxon help you? Over the time, Maxon has gained a lot of experience with different motor technologies. While in the past, Maxon has offered just DC motors, Maxon now has a wide range of different technologies, from brush to brushless, iron core, ironless, inner outer runner, but also other technologies. Just recently, Maxon has developed a 10mm stepper motor for a customer specific project. And on the other side, Maxon has also gained experience with direct motors, for example, linear motors or rotary direct drives in many customer-specific projects. Maxon actually has planned to launch a rotary direct drive, so-called Dynatorque, soon. So, and in addition to drive technologies and sensors and controllers, Maxon also had a lot of experience with customer-specific electromechanical systems. Maxon has already shown in many customer projects that we can also offer customer-specific systems, for example, a whole pick-and-place arm for the semiconductor market, or a complete door drive system consists of motor, gearbox, and housing. And we can use our know-how to improve your electromechanical system and offer you a complete solution and produce that. In case of laboratory devices, for example, this could be an entire pipetting cassette. Thanks to our global network, we can offer close support in almost all countries. Every business unit at the headquarters also ensure that customers in the respective markets are ideally supported, and our development team is closely working with the customer on the customer projects. Thanks to this wide range of products, Maxon has been able to gain experience in different markets and has developed new technologies that can also be used for other customers. We sell in all kinds of markets like medical technology, aerospace, automotive, e-mobility industry, and so on. So who are we? Maxon is a family-owned business since 1961 with its headquarters in Switzerland, central Switzerland. Maxon has over 3,000 employees, almost half of them headquartered in Switzerland. And we produce over 5 million drives per year. With our global network, we can take care of customers all over the globe. And thanks to the sales business unit that I mentioned, located at the headquarters, we can support our offices globally, and Maxon guarantees a market-specific global support in the project business, for example. And we have gained a lot of experience in different technologies over the years, from different winding technologies and gear technologies to sensors, controllers in every field. And the sensor and controllers are all designed in-house. This is a very important point, as the best motor often cannot achieve its full potential without the right controller. In addition to this, we also have a in-house manufacturing for many injection molding parts, for example, metal, ceramic, and plastic, which we produce in-house. And last, Maxon has gained experience in mechatronic design and system integration. In addition to our normal production facilities, we have also ISO 8 and ISO 7 clean room. These are mainly used for smaller motors with a diameter smaller than 10 millimeter, and for biocompatible and sterilized motors, which are mostly used in the medical market. And beside that, Maxon has a large number of certifications, including standard certifications for the medical and aerospace market. Our production is not just manual, it's also semi-automated or fully automated for some processes, for example, for the winding production or for the stator production for DC motors. Our facilities are all over the globe. We have around 9 facilities, and with that, we ensure to be close to our customers and avoid the risk of having the whole manufacturing at one single location. So, last, our solutions. We offer standard components, which you can find in our catalog, but also you can configure your drive online with some few modifications and get them within 11 working days. On the other hand, most of our business is customer-specific business. For example, semi-customized products, which means we do some modifications like special flange, special cables, and so on. And last but not least, fully customized products. For example, this pick and place arm or door drive. That's the area where Maxon wants to go in the future and where we can help and bring our know-how in your projects. So thank you very much for your attention. If you want to have more information on any products that I've shown or have any questions, feel free to contact me. Here is my contact information. So we will now swap over to the Q&A session. Thank you.